Hi, today we're going to talk about, we're going to start talking about bonding, but before we talk about bonding, I want to introduce one new concept, and we're going to talk about ions. Now, like that other word that started with I, isotope, isotope, remember, had the same number of protons, but it had a different number of neutrons. An ion has the same number of protons, but a different number of electrons. So an ion, all it really means, the definition, it is a charged atom. So you've seen these probably in some of the CASA learning questions. You'll see the Na plus or the Cl minus. These are ions. And ions actually conduct electricity, because electricity, all it is the flow of electrons. So if you're a sodium ion and you have an Na plus, you're going to be attracted to these electrons. And you can bring the electrons from one place to the other. So since it's a flow of electrons, that means electricity. So what we got to talk about, one thing about ions, is how to figure out the charge. So before we look at this, we're going to look at the charge of an ion, or the charge, we're going to look at the subatomic particles. So for example, if I'm looking at fluorine has 9 protons, and it's going to have 10 neutrons. Like I said, it's going to have 10 neutrons, and it's also going to have 9 electrons. Okay? Fluorine, if it is a nonmetal, when it becomes an ion, you change the ending. So fluorine is 9, 10, 9. Now fluoride, which you've probably heard about before, fluoride, I think there's fluoridated water. It has fluoride ions in it. Fluoride has still 9 protons. That doesn't change. It still has 10 neutrons. However, a fluoride ion actually has 10 electrons. Now what you do is you do a simple algebra problem. 9 plus, 10 minus. So you have plus 9, which is the protons, plus negative 10, which is the electrons, equals x. X represents the charge. 9 plus, 10 minus, this is a pretty simple problem. The answer is negative 1. So a fluoride ion is actually written F minus, and that's not your grade. That's the charge. Okay? We always write it as a superscript. That's the number above. So, or the sign is going to be above. It's a superscript, and that has the charge. If it would be, for example, oxygen, let me just show you an example. If you have something that is like a negative 2, you write oxygen, O, with a 2 minus. If you happen to write minus 2, you're not going to be deducted points on the regents. However, this is the intellectual and the correct way to do it. Now, let's talk about atomic radius and how it changes. So this represents the electron configuration. I'm going to do an example of sodium. We're going to do the sodium atom first. This is the fluorine. No, sorry, this is going to be chlorine. They're both in period 3, so they both have 3 orbitals. Sodium has 2 electrons in the first orbital, 8 in the second, and 1 in the third. And if you look at fluorine, it has, again, 2, 8, and fluorine has 7 in the valence. Now, if you remember back from the last unit, I told you that metals like to lose electrons and nonmetals like to gain electrons. When I draw this out, it makes a lot of sense now. I want to get to a magic number of 8. So if I were sodium, it makes more sense to get rid of this one than it does to find 7 electrons laying around. So metals have fewer valence electrons. They're going to lose electrons. If you look over here, chlorine has 7 valence electrons. It's much easier to gain an electron. So what's going to happen here is sodium will lose an electron, and as a result, it's losing an entire orbital. You notice that? I just erased it. So the ion has a radius, or the ionic radius is smaller for metals. Metal atoms are very large, metal ions are very small because they lost an entire orbital. When I'm talking about nonmetals, this chlorine is going to gain an electron. Whoops, one thing I forgot. Since I lost one electron, it is going to become a positive. Metals become positive. Chlorine is going to add an electron. And remember, electrons have a negative charge. So if I'm adding a negative charge, I now have one more electron. So this chloride ion now has a negative charge. And the last thing that I want to explain is when we write the Lewis structure, or the electron dot diagram for an ion. Positive ions are written like this. We're not drawing the 8 dots around it. Positive ones are written like this. Sodium lost that original electron that it had, so that original dot that you would put there, you get rid of it, and then you put brackets around it and put a plus. The chloride ion's a little bit different. What you're going to do is you're going to write the Cl, which we had 1, 2, 3, 4, 5, 6, 7. You're going to add that 8th one. You're going to put brackets around it and put a negative. So negative ions always have 8 dots, no matter what. They always have 8 dots. Positive ions have 0 dots, and a plus, negative, and 8 dots. Okay? One last thing, you're going to see a couple questions like this. Any nonmetal that becomes a negative nonmetal ion is going to have the same electron configuration as the noble gas. So phosphorus is going to have the same electron configuration when it's an ion as argon. Sulfide ion will be like argon. Chloride ion will be like argon. Nitride is like neon. Oxide is like neon. Fluoride is like neon. When we go over here, potassium, because it lost that, it's going to be 288, which is like argon. Sodium is going to be 2-8, just like neon. I don't know if you can see that way over there. Anyway, that pretty much sums it up. Practice problems.